Right, yeah, whatever. Okay. So anyways, the properties of a rhombi or a rhombus is the same exact thing as a parallelogram. Okay. So we have opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary, meaning they add to make 180. So if I cover up half the picture, they add to make 180. Diagonals bisect each other. Meaning the lengths bisect each other. We talked about a parallelogram and we talked about a rectangle. So when we did a parallelogram, these pieces were congruent to each other, but that does not mean that they're all congruent. When we did rectangles, all the diagonals were congruent to each other. So a rhombus is like this because this length is going to be longer than this one, obviously using your eyeballs. They are not the same length. Okay, so keep that in mind. The two new things that we are adding for this is, first off, a rhombus is like a zesty square. Okay. So it's like a square, just like squished a little bit. So the first thing is that all four sides are congruent. They are congruent to each other. The next thing are that diagonals are perpendicular. So perpendicular is an upside down capital T. If you do not know that, by the time you take your EOC, you're going to need to know that symbol. It literally means perpendicular. Perpendicular technically means what? It means 90 degrees. So it's creating this little square in the corner. It's creating a 90-degree angle. Okay. So the diagonals, when they cross each other, they're creating a 90-degree angle in the center of the picture. And then number three, the last thing is that the diagonals, and this is what you guys were trying to do with all the other pictures, the diagonals are creating angle bisectors. So they bisect the angles. So not only is it bisecting in length, it is bisecting the angle that it's intersecting with or touching. So these are our new kind of things. So we're going to kind of jump around. Let's go to number 4 to start. So for number 4, and I'll leave this up here for a second because people are still writing. For number 4, if you look at number 4, it's talking about just the angles. The angles are harder to find than the sides. So for number 4, I'm going to scoot down to number 4 now. If I look at this picture, paper is like kind of the way. Okay. So if I look at number 4, I have 1, 2, 3, 4, 5, 6, 7, blah, blah, blah. I'm trying to find all this mumbo jumbo. Okay. If this is 38 degrees, that's the only angle that is given. Where else can 38 degrees go? It can go at 4. So we'll put it up here, 38 degrees. It can also go at 3. So the reason why we said 4 first is because this is alternate interior like we did before the weekend. Number 3, I can put it at number 3. The reason why is because the new thing that we learned today is that it's creating an angle bisector. So if this side is 38, this side's 38. So then where else can 38 go? 5. So I'm gonna put 38 over here. Boop, boop. Okay, so let's fill in what we can so far. 3 is 38 degrees. 4 is 38 degrees. 5 is 38 degrees. And then that's it so far. That's the only thing I have. That's the only number I was given. So does anybody think that they know maybe how I can find another number? Oh, yes, perfect. So all of these angles smack dab in the middle create 90 degrees right in the middle. So the diagonals are perpendicular. So all of these intersections right here are 90 degrees. So I can make number 8 90 degrees because the diagonals are perpendicular. So I got that one. How else could I find 1, 2, 6, or 7? I could do it. I'm thinking 2 different ways right now in my brain. Yes. Yes, that will give me the same thing, but that's going to confuse everybody. So is there another way? That's correct, though. So you could look at it as a triangle. So inside this shape right here is a little triangle. Boop, 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 boop. This is also probably going to confuse people, but this one makes more sense than the other one. A triangle adds to make 180. 180 minus 90 minus 38 will find angle 2. And then that can also match with the rest of the numbers. So let's do that. So if I know a triangle adds to make a total of 180, if I say, I don't know, x plus 38 plus 90, you don't have to write this if you understand it, but if you're lost in the sauce, like some people are, which is totally fine, that's the equation I'm using to solve for angle 2. What do you end up getting for that third angle to make a triangle? 52. So angle 2 is 52 degrees, angle 1 is 52 degrees, angle 6 is 52 degrees, and angle 7 is also 52 degrees. The last way, can anybody think of the last way to find one of the angles? Perfect. So another way that you could have did it is if you cover up one of the sides. Remember, half of the shape is going to make 180 because the whole thing makes 360. So you could do 38 plus this angle over here equals 180. And then whatever you get, you divide by 2 because they're 2 equal parts. So any of those 3 ways makes the same thing. Okay, you get the same answer. Either way, you should end up getting 52 degrees. But within these pictures, you're going to see triangles. So use that knowledge that you have of triangles to make 180. Triangles are going to keep popping up multiple times throughout like the rest of this year. And then you're going to go to algebra 2, and then you're never going to see a triangle again in your life. There's going to be no more shapes. Unless you go to, no, well, unless you take trig, but I don't think they even offer trig anymore in high school. But anyways, okay, moving on. Let's go to number 5. So number 5, you have a blank picture, but there's information that's given. So take a second, take the information from number 5, put it in your picture. This one's going to be a little difficult because we need all the side lengths and we need the degrees. So there's going to be lots of numbers in this picture just because they're asking for literally everything. On your EOC, they're never going to have a question with 27 blanks. Okay. They're going to have, it's usually max of 3 blanks. Just an FYI. Okay, so let's talk about what we know. The inside of the triangle, remember, or the inside, this is a degree versus the lengths. When you have lots of numbers, it kind of gets a little confusing. So I put my little degree there, but just bear with me. What's up? WY and ZX are not equal. No. The diagonals are not congruent to each other. They do bisect each other, but they are not congruent. This is definitely longer than this side. So from W to Z, what is WZ going to be? 34 because all sides are congruent. V to Y. Where is V to Y? I don't even know. Oh, V to Y is right here. So what is that going to be? 19, because if you take 38 and you cut it in half, that's going to make 19. If I need Z to V, from Z to V, do I know what this diagonal's length is? No. So I'm trying to find Z to V. Yes. BY, yeah, wait, it's 38. It's 38 divided by 2, not 34. Yeah, you put 34 in the wrong spot. 19 is from dividing by 2. So this is 19 and this is 19, because if the entire thing is 38 across, 38 cut in 2 is 19 and 19. Okay, so now we need to find Z to V. So if I'm looking at Z to V is from here to here. Does anybody think that they have an idea of what I could do? Yes, you have to use the Pythagorean theorem. So if I'm trying to find Z to V, I know I have a right triangle. Anytime you have a right triangle, that should be a red flag that you're probably going to have to use a Pythagorean theorem at some point. That's a 90-degree angle in there. So I'm going to use the Pythagorean theorem. So if I have a right triangle, the hypotenuse is 34. I know one of the sides is 19. I'm just going to make it the shorter side for just the way the picture looks. And I'm trying to find this side, which is Z to B. So I'll just call this A because it's either A or B. It doesn't matter. It's one of the legs. So I'm going to use A squared plus B squared equals C squared. C squared is the hypotenuse. It's always the diagonal. So if I take A squared plus 19 squared equals 34 squared, what is 19 to the power of 2? What is it? 361. Yeah. What's 34 squared? Perfect. And now I can minus 361 to both sides, and then I can take the square root. So I have A squared equals 795. If I take the square root of both sides, bloop, 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 what is A around? It's a decimal. 0.2. You do have to round it just to the nearest tenth. Yes, take the pass. So this is 28.2. So I'll put that in my picture, 28.2, 28.2. So if that little piece is 28.2, what is Z to X going to be? Perfect, 56.4. So now that's the side lengths, the sides you're going to use Pythagorean theorem. Now we're going to find the angles on the inside of the shape. So if I know what I know, the only angle I technically know is 34 degrees, okay? So I need to find WXZ. So if I start it up W, I go to X and I go to Z, what is that angle right there going to be? Not 28.2. There's only one angle I know, which is 34 degrees. What would be on the other side of 34 degrees? 34 degrees. Because it's
What?
It's an angle bisector. So if this is 34, on the other side is also going to be.
Dude, this is confusing because I thought you were just saying how 34 like wouldn't equal that angle and it goes on the other side.
It could, but that's a parallelogram. A rhombus is technically a parallelogram, but it has more steps. Not more steps, but more things. They're saying that it's the diagonals bisect the angles, and the most important thing is that your diagonals create a 90-degree angle in the center, which only works with rhombuses and squares. Okay. So WVZ, if I go from W to V to Z, I'm talking about this inner angle. Shh. What is this going to be? 90 because it's in the center. ZYW, if I start at Z, I go to Y, I go to W. I'm talking about this angle right here. ZYW. I don't know anything over here, but if no, that's a length. If I know that this is 34 and this is 34, think about it. This is 34, this is 34. They have to add in total. This whole side needs to add to make 180. So if I take 180 and I minus 34 and I minus 34, what do I get for this whole angle over here? 112. And then if I divide by 2, I get 56. That means each of those angles is 56 degrees. The last one is XYW. XYW is going to be what? $56. Because they're congruent. It's an angle bisector. Yes. Oh, I'm sorry. I didn't even realize that. Let's go to the backside. Because we're going to talk about squares.
What?
A square is a rhombus.
What was
A square is technically, a rhombus is technically a square, okay? That has two extra things. So the only thing that we added today with the rhombus is that it has the congruent sides So it's a parallelogram, but it has 4 congruent sides. The diagonals are perpendicular, meaning they're creating 90-degree angles, and the angles are bisecting each other. A square is actually easier than that because there's only 2 new things, and it's common sense things that you should know from realistically like a long time ago. 4 right angles, that makes sense. It's like a rectangle. It creates 90-degree angles. And the last thing is that the diagonals are congruent. So you may want to underline those or put a star or maybe highlight it or use a colored pen to highlight it. A square, the only difference is it has all the same properties, but it has 4 right angles and the diagonals are congruent. So let's do number 6 together. So take your information and put it in your picture for number 6. It's a square. You're going to like the square better than the rhombus.
Any of it.
Well, you know, nobody enjoys math class, so.
I knew everything.
Pythagorean theorem. You're slightly off. It's 15.6. You're wrong. 15.5 is not the same thing as 15.6. You're wrong. 5.6 rounds up to 15.6. Okay. ABCD. ABCD is a square. AD is 11. We're going to find all of this missing information. You're going to like this one. Yes, you will. Shh. What is BC going to be? 11. What is? Shh. Please be quiet. Please be quiet. If BC is 11, I also know that DC is 11. I also know that AB is 11 because it's a square. Shh, be quiet. All the sides are congruent to each other. Can you stop talking? Shh. Stop. All the corners are congruent. We need to find A to C, which is the diagonal of a square. So it makes a right triangle, which is the Pythagorean theorem. So we could do A squared. This could be A. This could be B. We're trying to find C, which is the diagonal. So we're going to do 11 to the power of 2 plus 11 to the power of 2 equals C to the power of 2, which is the diagonal. So 11 squared is 121. 11 squared times, or 11 squared plus 11 squared is 242. Thanks. 242. I'm going to shift square root. So C is around 15.6. So this whole diagonal is 15.6. So from A to C is 15.6 because the Pythagorean theorem says so. B to D is going to be what? 15.6 because the diagonals are congruent now. What is EC going to be? What would this little portion right? 7.8 because I'm literally taking it and I'm cutting it in half. Now the angles are fun, and I know you hate the angles, but the angles on a square are easy peasy lemon squeezy. Okay. So DAB, if I start at D, I go to A, I go to B, it's talking about this whole angle A, which is 90 degrees because it's a square. The next one is AEB. If I go from A to E to B, what is the inside diagonals creating? 90 degrees. Because the diagonals are perpendicular. No, I don't. CBD, not like the drug, CBD, okay? CBD right here, and right here. What is this little angle right here going to be? 45, because it's an angle bisector and the whole thing is 90, so cut in half is 45. BAC, BAC is going to be what? 45. We're going to set up one more together. I think you'll like the squares. So I want to do a rhombus problem together because I think the squares are easy. So let's go to number 9, last one.
You
I am not doing all of them for you because you guys have big brains and I believe in you. So number 9,
What's this do?
Wednesday. So yes, Wednesday. Is this the same problem? No, it's not. Okay. C, D, E, F is a rhombus. Find the measure of FED. So FED is this angle right here that I'm trying to find. FED. What am I going to do with these two angles if I know it is a rhombus? No. Set them equal because it's an angle bisector, meaning that this angle is congruent to this angle. So I can put an equal sign between them, solve for x, and plug it back in. So I'm going to do 5x plus 1 equals 8x minus 20. Take a second, solve your equation. I'm going to add 20 because that's easier than subtracting 1. So if I add 20 to both sides, 5x plus 21 equals 8x. Now I can minus 5 to both sides. So I get 21 equals, why am I having a brain fart? 3. Jesus, I can't even subtract. Divide by 3. So x is 7. Now I have to think about what I'm trying to do. If I know x is 7 and I'm trying to find this angle over here, let's start by plugging it in maybe. Okay, if I plug x in, what is 5 times 7 plus 1 going to give me? 36. So this angle is 36 degrees. What's going to be on the other side of my little 36? How could I find what FED is going to equal? Beautiful. So I'm going to add them together, subtract it from 180, and that's going to give me this angle because if I cut it in half, half the picture adds to make 180. So I'm doing 36 plus 36 plus, I'll just call it angle E because whatevs, equals 180. So basically I'm taking 180 and I'm subtracting 36 twice. You don't even have to write an equation. So what do you end up getting for this angle? What? No. 108. You took it, Luca, and you divided by 2 because you found each angle. This wants to know the whole angle. Each one would be 54, but this, in this case, is 108. I know you think I hate you, but I love you guys. Don't hate me. No, I do.